I love the Raspberry Pi. I know a lot of people love the Raspberry Pi. So in the Arduino, it's got a microprocessor chip. You connect it to a computer, you write your code, you upload the code to the chip. And at that point, your code is on the chip, and the controller will perform whatever function you've told it to do through your code. This guy here is a full computer. So you can think of this little guy as a mini computer. You could hook this up to a TV, for example. People have set up emulators on this, so you can run video game consoles, early emulator versions through this. You can build robots, do whatever you want. So these are all other options available to you. Now this is quickly growing to be one of the fastest, most widely used microcontrollers in the world today. It is not Arduino, it's not Raspberry Pi, it's a WeMOS Wi-Fi mini board. So you have a full microcontroller and integrated Wi-Fi module. So in the past, Wi-Fi was very challenging. There's a lot of work to get going. Today is integrated Wi-Fi and microcontroller. And what people are doing with this is really cool. So scientists, instead of having one sensor, they can have 100 of these little sensors set up somewhere. So for biologists, that's very useful. They now have 100 different data points at a fraction of the cost of what it usually takes them to get a sensor connected to a Wi-Fi. So anywhere you have a Wi-Fi signal, you can have this thing out in the field, and it'll beam your data through the Wi-Fi network to any computer on the world that you want to. Or you can, through the Internet of Things, automate it through your smartphone. So you can control any function with this little guy through your smartphone, because smartphones have built-in Wi-Fi as well. Anywhere that are set up, and you have access to. And people might want to stand up to get a closer look at some of these. So a very common thing to do is to make stuff move with these microcontrollers. So to make stuff move, you have hundreds of options, thousands of options. I brought 3 here today. You have general 180-degree rotation servos here. So they move 90 degrees to the left, 90 degrees to the right, and 90 is their middle stop position. So 90 is default stop. They can go down to 0 degrees or up to 180 degrees. They only go 180 degrees of rotation, but if you have a little walking robot or something that only needs to move a little distance, these things are great. Now there also exist 360-degree servos. So these guys will rotate. You can use these as wheels on cars, for example. There's a lot more functions you can do with these guys. Now you can also connect up stepper motors. So any stepper motor or other translation stage, whatever it is, you can also connect to these $5 microcontrollers here. And it's very easy to control them. And actually that's one of the demos I've got set up over here, which I'll show you in a bit. So of course there are touch screens. You can connect it through a microcontroller, have a touchscreen interface for what you're trying to do. You also have regular LCD displays you can use. So this is a neat little 5 milliwatt laser module here, very low power, but you can just as easily hook up a large laser as a small laser controller with one of these guys here. So a little solenoid push rod. It's got a spring in it. When it's got electricity, it holds it. When it releases electricity, it pops up. So a little push rod, throw a little switch somewhere. We of course have joystick pads. People who are at the first workshop got to hook one of these up. Unfortunately today, we're not hooking one of these up, but we're doing some other fun stuff today. But lots of people like joystick pads. You can use this to control anything that you want, anything that you tell it to control. So we have other sensors as well. Soil moisture sensor, a 3-axis accelerometer. I'll show you over there as well. So this one is fun. It is 3 axes of rotation, so X, Y, Z. And you can put this on your robot and know which way is tilting, which I've done over there, and I'll show you in a bit. Okay, humidity and temperature sensor. So this detects temperature and humidity, those two both. It's great if you have a sensitive equipment that you want to monitor the humidity with, for example. We have a passive infrared motion sensor. So this, you probably have noticed if you walk in, I guess not this room, but if you walk in most bathrooms and you look up, you see this guy on the ceiling. And what it is a passive infrared sensor. So it does not detect specific location, it just detects movement in the room. And so it sees when you walk in the bathroom, it doesn't see specifically you, but it knows there's movement in the room, and you can use that to turn on a light, for example, as is commonly done. Okay, a rangefinder. So this is an ultrasonic rangefinder. So just like a bat, echolocation, sends out a ping, and it listens back, and you put it in the code, you calculate, so you can actually adjust it for the speed of sound. And if it's a moist, damp day, you can actually change it in the code, adjust that to try to tweak it to get it more optimized to what function you need. And then what people will be playing with today, I love photoresistors. These are fun little guys. So you'll be making this turn on and off an LED today. That's one of the lessons you'll be doing. So it's a photoresistor. I think most people know what these are, but it's got you'll see a little interface there, and depending on how much light is impacting incident on the surface, it'll change its resistance. And so of course a microcontroller can detect that using the analog pin. You can have that as a switch, turn something on and off, for example. And then we have solar cells. So these are just another addition that you can use. So you can use enough of these, you could power actually a robotic installation like this.